Okay, so let's go for round two. So, uh, basically, this is just summing up what I'd like to do in the future. Uh, as we have different rock types, so this is two types of mica, biotite muscovite mica. As you can see, it's a platy material. Sorry, my screen's over here. It's not behind me. So, if I wanted to look at the screen, I need to actually turn it. And here we have a schist. So, I've been going around with my work and getting different formations. So, I do have some from down Geelong way. Most of that is either sedimentary rock. We do have a lot of Cretaceous rock down there. There's a Permian, there's granites, but there's a lot of tertiary rock. So we've got the baked limestone. And so I do have a large slab. I'll make another video. It's calcareous limestone, so it's just broken up shells welded together. When it's fresh, it's like a whitish color. And then when it's eroded, so obviously it has to be eroded in place. And it gets a lot of imprint with iron, so it changes it to a yellowish, orangish color, which is very interesting. You can see some fossils in the actual material. But basically, when you're doing this stuff, you need to read up on the current research. Okay, so I did make a video on the Morable Viaduct Formation. The material that I showed in that video did not come from that formation. It was the Batesford limestone. I just needed to hunt down where the actual material came from. But anyway, as an example, we've got the Morable Viaduct Formation. So that's the incorrect name. Also, the spelling is wrong. So Morable Viaduct Formation, this is the former name. Then they changed the name to Morable Viaduct Sands. And we have some information about what they included. So the definitions about what the material is also changed. Okay, pebbly quartz sandstone, ferruginous polymictic conglomerate. So it just means it has a lot of iron. Polymictic means it's made up of different materials, so it's not just all the cobbles are not just, conglomerates has cobbles in it. They're not just one type, so they don't come from the Silurian siltstone or sandstone, or even the Devonian granites. And then we have the movable viaduct sands. So there's quartzose, so very hard sandstone made of quartz. Calcareous sandy clays to coarse grained quartz sandstone. So obviously this is not a calcareous material. And then they decided to get rid of all these names and they included it into the so move it over here, the Sandringham sandstone. So here's a pretty extensive description, and this actually gives information from different formations. So here, okay, I need to take my hand off. It's a bit confusing from my left and right. It's a bit confusing. So, what we have here, we have the Sandringham sandstone, and in 2016, this replaced all these formations down below. So we've got the Hanson Plain Sand, Morgul Viaduct Sand, Baxter Sandstone, Maria Cove Sand, the Black Rock Sandstone, the Red Bluff Sandstone, Belmoros Sandstone, and the Brighton Group. So, obviously, a lot of smaller formations have been combined into a bigger formation as more research has been coming along. And a lot of those names are probably from the 1800s. Oh, a little bit tired. When research is actually starting to take off. So, what we're going to use is, we're going to use this. So this is the surface geology of Victoria. So if you need to go down into the actual bedrock, you need the actual geological maps. But if you search the Geological Society of Victoria, you'll find that a lot of maps for a lot of regions are not uh, included. So they do have maps, but a lot of them are not digitalized. So here we have an index. So the yellow and the whites are all more recent material. If we go over to the actual reddish color, so this stuff here, this is all intrusive. So this is the cowbell batholith. Can't remember the names of a lot of these. I know that one's pretty famous. Then we've got another batholith down below. I need to hunt down the names of these. There's just so many of them. So these are all Devonian granites and granodiorites. I don't think any of them are diorites. Then we have the purplish colour, which is more metamorphic rocks. And as you can see, it makes up a lot of the highlands. So all this material here is the highland area. And a lot of it is, so the purplish colours here, these are Silurian and Ordovician material. So, where did I go before? Oh, sorry. Went up to Heathcote. So here we have a greenstone belt where the Cambrian rock has been pushed up to the surface, as well as we have some which I haven't around over here in the Rangarata region. I need to find where that is. It's a less of an exposure. Here we have the Grampians, Grampian Formation, sandstones, siltstones, and mudstones. And up north, we have a lot of recent sedimentary rocks. So this lightish yellow colour here, this is all the Shepparton Formation. So as you can see, it's quite extensive. It's about 3 million years and younger. A lot of it's in the channels. Another formation, I can't remember the name of it, is being deposited. If we go down to 12, we might be actually able to find the actual formation itself. Oh, 10. Okay, maybe 11. Okay, down below you got the actual formation. So NWS. So NWL. So NWS is over here. Loxton Sands. Now maybe we want to go down Shepparton a bit more. Okay. We'll restart that again. So obviously 12 is not good. Maybe 17 or 18. Okay, 17. So in these watercourses here, we have more recent depositors been put in, but this has all been eroded away. As far as I know, there is no real deposition. And you see the rivers are more straight. These are all man-made canals or former rivers that have been hijacked and used for agricultural purposes. Okay. Yeah. No, we don't have any information. I'll need to actually look that up. I did before. I know it starts with C, but I just can't remember. So QA1 is the recent formation alluvium. Okay, so what I'd actually like to do is go through each one of these and just analyze the actual formation. So the first, 18, going to be pretty similar, but as you get down to 16, you do get some different material. And when we hit 19 or 18, 19, that's when it really changes. And definitely in map 20, so the Talagata Koryong area, we get a lot of intrusive material. So very, very good. Okay, so if we look at the first map, this is Lindsay Wentworth. So this is the northwest of Victoria. It's west of Mildura. So if we go down to the next map, we have Mildura here. So it's the actual township itself. And what we have here, we have a quite simplified geology. So obviously it doesn't include the New South Wales portion, but most of it is the formations are recent. So we've got a lot of lake deposits, lunettes associated with lakes, and bordering dune deposits, alluvial terrace deposits, alluvium. So most of that's associated with former lakes, which is this part here, as well as the current Murray River, which is up here. And we have a lot of current watercourses and lakes that are part of it. Okay, so the first formation, so these actually go chronologically. So the Blanchdown clay, which is associated with former lake systems. So the Blanchdown, Lake Blanchdown, I think it's called. And we've got a large one here. Got some more here. Actually, the lake included most of this map. So I'm not too sure exactly when that lake was, but when I do more research, I'll actually have the information available for you. Then we have the Warrior Formation, and that includes most of this. So this is probably former ocean, and then we have the Yamba, and Loxton Sand strand lines. So as the actual, so this used to be underwater. So as the ocean retreated, it deposited the Loxton sands, so strand lines, and the Amber Formation, which is this part here. I need to look that up, so I'm not too familiar with the Amber Formation. And then we have the Danyo Fault, obviously exposed at the surface, so it might be more recent. Actually, it's in this one. So it has to be, so Q is quaternary, N is neogeny. And another thing is that um, on these different geological maps, they use different definitions. Oh, probably not definitions, different. So these three words, symbols for these formations on this map, they use these. And if we go to, okay, if we go to another geological map, yeah, if yeah, it doesn't want to work that well. Okay, I don't think I have one this area. Maybe Ballarat, we'll have a look. So this is an older map. This is more hand-drawn, cartoonish. And we have different colors in this one. So this one's not good. So the older the map, the different it would actually be. So this is just color coded, so you need to interpret it color wise. If we look at the Casterton, yeah, that's pretty much the same. How about Dartmoor? I'm gonna Okay, this. Okay, so this has symbols Q1, Q2, so quaternary, Q4. Okay, so you got QPD. So if you go over to the actual side, and you can find out what QPD is. So this gives an actual date of the actual material. QPD, cross-bitted dune, limestone, aeolianites, and calcareous sands. Of a fixed calcareous dune system associated with interdunes fossil soils. Okay, so it's not named. And then we have other formations, so Glenelg group. So the current definition is that so the night group. So this is older definitions. Usually they put an E on it or Eocene. I have to come up with okay, maybe the Shepparton formation. I can use that. Wangaratta. Okay, this map looks a lot more recent. QS, yeah, Shepparton. So Q for quaternary, S for Shepparton, and where is the information about the actual? Okay, okay, this is starting to use terms that we would use now. So Ordovician, Upper Silurian, Devonian, Tertiary. Yeah, this is still not current. So how about Nagambi one should be okay. So a lot of these geological maps, they use all different terminology. So when you go to have a look at them, you get a bit confused. Okay, so this one uses the current terminology that they have adapted. So you got the first letter for the period, so Devonian, Silurian. Uh, okay, that's a bit out of place. This J, that should be your DJ or whatever. Okay, then you got Silurian, and then you got granites. So the granites they use G. Then you got Permian P. Then you got tertiary and quaternary. So that's what Q and T. And not always. Uh, the second letter is usually an L, M, mid, or this says QV, so volcanics. So it doesn't have a date associated newer. So this is how it should be. You have the first letter for the period, the second letter for a place in that time period, and the third letter is the first letter of the formation. So Batesford, Devonian, late Humavale, Devonian, late Puckapunyal, and obviously DLF, they've probably DLW, they probably use it as something else up here. So Norton Gully. So Devonian, late Valhalla, Norton. So basically, that's definitely how they should use it. So while we do have the names of these formations, a lot of the times they have changed. Like up here, NBB, that is the Black Rock Sandstone. Then we've got MBR, NB. So all of these formations, okay, these three down here, have been put together into the Red Bluff Sandstone. So the MBs that we see, that's why they all have the same NB definition. Although this time, uh, what date is this? Huh, I don't know. So what we are talking about is this one, and the MB will be included as the same formation. Though I need to read up on it. That's just something I've actually learnt today. So, anyway, let me know. Let me know what you think will be a great thing to actually talk about. I'm just very interested in doing this whole series of the actual state. And I'd actually like to know if the other states do the same thing, just split it up. I think I will probably focus on Tasmania. I've been down there. It seems quite interesting, the actual geology. Anyway, thank you, and maybe I'll talk to you later. Bye.